All right, now it's time to put it all together so we can solve the exact value of trigonometric expressions. This will be at the beginning of any test you take. No notes, have to solve it, and you don't necessarily have to solve it in this manner, the way I'm about to do it, but this is the steps. Now, some of y'all will have a quiz or a worksheet where you're going to have to follow all these steps. I don't care about the answer, I care about how you get to it. But once you get on ground and you take a test, you don't have to follow all of these steps. You just need to know how to solve it. But at the beginning, I'm going to force you to solve this way. So before we do, let's put in a couple pieces of information. Where we have just what is everything equal to? So we have cosecant of an angle is equal to 1 over sine. Which means if you know sine of, I don't know, maybe you know sine of pi over 3 is equal to root 3 over 2. This is saying you also know cosecant. This 1 over says take sine and just flip it over. And you get 2 over root 3. Maybe you're one of those nerds that your teacher in high school is like, you can't leave roots in the denominator. You can't. Calculators will never be able to solve that. That's a holdover from back in the day. See, for me, on a test, I love it. For your homework, 90% of the time it's going to take it. But maybe you need to do one of those. You know what I mean? 2 root 3 over 3. That's neither here nor there. What we wanted to get to, we just wanted to get the point that when it says cosecant is 1 over sine, it just means if you know sine, you know cosecant. Flip it over. Same thing is going to be true for secant. If you know cosine, it's just the reciprocal of it for secant. Similar with cotangent. But shoot, dude, all you got to do is be pro with sine and cosine. Sine and cosine. They're all made up of sine and cosine. So I don't need you memorizing every single value for cosecant, secant, cotangent, tangent. There's no need. We must be pros with sine and cosine. If you're a pro with sine and cosine and you know these identities, shoot, we'll be good. Now, the next piece to be successful is we better know this table. We got to know these tables. You know what I mean? Like if I was to give you, all right, what's cosine of pi over 3? You'd be like, cosine pi over 3, it's equal to the ratio 1 over 2. Which means if you were to make a triangle, say, oh, the angle's pi over 3. The adjacent would be 1, and the hypotenuse would be 2. That's a triangle. There's infinitely many triangles that makes that true, but I'm not going to get into that. But that's why this 1/2 is the ratio of the triangle. And I think a lot of students lose sight of that because it just becomes a big puzzle. So we're going to use this. This gives us the answer to all of our reference angles. Those reference angles from the last video. So once we know our reference angles, and we know this one little piece here, A, S, T, C, know that, and then know what coterminal means? Shoot, you're going to be unstoppable. So here's an example of a worksheet that I might give out to students. Maybe this is your worksheet. I don't know. So I give the rules of the game. Because I'm trying to get you led into how do we do this. Rules of the game. First thing, part A. We want to find a coterminal angle between 0 and 360 or 0 and 2 pi. Depending on whether the angle, depending on whether the problems are in degrees or radians, right? If it's in radians, like problem 1, keep it in radians. Don't switch it over to degrees. Now, if the given angle is already between the intervals, just state the given angle. So let's go to number 1. Part A. We want to know, is 5 pi over 3, is that already in between 2 pi and 0? Is that true? Yes, it is. So we're just going to state 5 pi over 3. Because if it was 111 pi's over 3 or something, you're like, dude, let's get that smaller. Let's get it smaller. So there's step 1. We just looked and we're like, it's already in between 0 and 2 pi. So we just write it down. Next, it asks, what quadrant are we in? For part B, state the quadrant for which the angle lies. If it is quadrantial or any of these angles here, so I'm just writing zeros, but they're not in quadrant 1, they're not in quadrant 2, they're not in quadrant 3, then you state it. So we look at B and we're like, okay, where is 5 pi over 3? So we have 0, we have pi over 2, we have pi, we have 2 pi. Why am I writing something different than what I'm saying? Well, since we have a 3 in our denominator, do you want to write it like this? You want to just write 0 and 2 pi each time? And then guess or memorize? Sure. But since there's already a 3 in our denominator, it's like, we'll give it a 3 top and bottom. Change 2 pi. Did you know 6 divided by 3 is 2? Of course you do. So what's 1 less than 6? 5 pi over 3. Oh, so we're in quadrant 4. We're in quadrant 4. All right. Well, we're moving right along, getting it done. Now the next part says, determine the reference angle from part A. But fortunately, we're already in radians. Reference angles are mellow. That's just pi over 3. See it? It doesn't reduce down. It's just pi over 3. Now we're going to use this to determine the exact value of the trigonometric function. So what we can say here is, well, this part's not going to tell us much, but quadrant 4, ASTC. It's in quadrant 4, which tells us, oh, our answer is going to be negative. So we say equals negative sine of the reference angle. We just take what we got from part C and we pop it in. Well, pi over 3. Now what's sine of pi over 3? Let's go back up. What's sine of pi over 3? Oh, sine of pi over 3 is the square root of 3 over 2. So it's telling us the answer is negative square root of 3 over 2. And there's the solution. And we're going to continue doing this game throughout the whole thing. So that was part D, is just to actually answer the gosh darn question. Now please make certain, you notice how I used equal signs? Make sure it's equal. Make sure it's equal. Don't write equal signs when things aren't equal. Math teachers get all cranky about that crap. So then we're going to continue on. You'll get some degrees. Have fun with degrees. Degrees suck. More degrees. But then we get into something like this. Like let's just look at sine of 29 pi over 6. So part A is going to ask us to find an angle in between 0 and 2 pi. Because 29 pi over 6, that's too big. That's bigger than 2 pi. So what we want to do is we want to find something that it's coterminal. So this is clearly too big, right? So our game is going to become subtract out 2 pi until it's in between 0 and 2 pi. Coterminal. We're just saying we're at 29 pi over 6. We've spun around too many times. It's too big. I'm not trying to memorize 29 pi over 6. What quadrant's 29 pi over 6 in? Yeah, I don't know either. That's a lie. It's in quadrant 2. Common denominator, multiply top and bottom by 6, you can get the same thing. And we're like, oh, 29 minus 12, isn't that, what is that, 17 pi over 6? But shoot, this thing's still bigger than 2 pi. That's 2 pi, isn't it? So we're going to do this game one more time. We're going to take 17 pi over 6 since it was too big. Let's subtract out 2 pi. Multiply top and bottom by 6, so we have a common denominator. So we multiply the bottom by 6, you got to multiply the top. What's 2 times 6? 12. Now when we subtract it, we get 5 pi over 6. Woo! 5 pi over 6 is in between 0 and 2 pi. So there we go. It's 5 pi over 6. And the reason we do this is coterminal angles plugged into trig functions are exactly the same. So now I don't want to look at this anymore. Those numbers are too big. We can think about sine of positive 5 pi over 6. Let me get rid of this. Next step. We want to figure out what quadrant are we lying in. Well, 5 pi over 6, well, that thing's 5 divided by 6 is pretty freaking close to 1. Well, let's play that same game again and give it the same denominator on the pi. Or maybe we do it on a 12 pi over 6 for 2 pi. Well, we go, hey, it's less than 6. So it's got to be there. We're in quadrant 2. Is sign positive or negative in the second quadrant? It's positive. That's why we looked at this. Now, what's our reference angle? We look at 5 pi over 6. We're like, just take the 5 off and we get pi over 6. I'll write it down at the bottom. So for part D, we say sine of 5 pi over 6 is equal to either positive or negative sine of its reference angle. And are we positive or negative in the second quadrant? Oh, we're positive. We look at our table. And what's sine of pi over 6? Oh, it's 1/2. So our answer is, sorry for the scrolling, you getting dizzy? Getting dizzy? Is positive 1/2. All those answers are coming straight from that table. And then I got some tricky ones down here. Just for those of y'all that like to listen. 0 pi. 1 pi. 2 pi. 3 pi. 4 pi. 5 pi. Do you notice anything? These are even pies. These are odd pies. So isn't this the same thing as cosine of 1 pi? 1 pi. Trick. Trigonometry is not algebra. You should learn all the tricks, all the shortcuts, all the fast ways through things. So I don't know if you're in, like, say, a trig hybrid class right now. This would be your quiz, or actually it's a worksheet that would be due at the end of the week. This is how we solve it. If you have any questions on it, you should reach out to a past bear, reach out to me, or just suffer in silence and struggle your way through it. It's all up to you. But this game, we're going to be doing this. This will be, except without all the part A, part B, part D, C, D, all that crap. Your first exam, no calculator. You're going to get questions like this. Give me the exact value. 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 And you're going to have to do this without a calculator. And we're going to have to do this not on just our first section, like chapter 2. Nope, we're going to do it in chapter 3. We're going to do it in chapter 4. We're also going to do this in chapter 5. It'll be on your final. It'll be on every test. Skipping past this is a silly, silly thing, because it's going to make everything 100 times harder if we don't understand this. So do not skip this. Be pro with it. I mean, if you have questions, you want more problems, let me know. I will hook you up, because this is big. So sorry for such a long video, but this one's important.